In this lesson, you will learn how to configure local and remote logging on FortiGate, view, search, and monitor logs, and protect your log data. In this lesson, you will explore the following topics: log basics, local logging, remote logging, log settings, view, search, and monitor logs, protecting log data. After completing this section, you should be able to describe the log workflow, identify log types and subtypes, describe log severity levels, describe the layout of a log message, describe the effect of logging on performance. By demonstrating competence in log basics, you will be able to more effectively analyze log data from your database. When traffic passes through FortiGate to your network, FortiGate scans the traffic and then takes action based on the firewall policies in place. This activity is recorded, and the information is contained in a log message. The log message is stored in a log file that is then stored on a device capable of storing logs. FortiGate can store logs locally on its own disk space or can send logs to an external storage device such as FortiAnalyzer. The purpose of logs is to help you monitor your network traffic, locate problems, establish baselines, and more. Logs provide you with a greater perspective of your network, allowing you to make adjustments to your network security if necessary. Some organizations have legal requirements when it comes to logging, so it is important to be aware of your organization's policies during configuration. For effective logging, your FortiGate system date and time should be accurate. You can either manually set the system date and time, or configure FortiGate to keep its time correct automatically by synchronizing with a Network Time Protocol (NTP) server. An NTP server is highly recommended. To FortiGate, there are three different types of logs: traffic logs, event logs, and security logs. Each type is further divided into subtypes. Traffic logs record traffic flow information such as an HTTP/HTTPS request and its response, if any. It contains subtypes named forward, local, and sniffer. Forward traffic logs contain information about traffic that FortiGate either accepted or rejected according to a firewall policy. Local traffic logs contain information about traffic directly to and from the FortiGate management IP addresses. They also include connections to the GUI and FortiGuard queries. Sniffer logs contain information related to traffic seen by the one-arm sniffer. Event logs record system and administrative events, such as adding or modifying a setting, or daemon activities. It contains subtypes named endpoint control, high availability, system, user, router, VPN, WAD, and wireless. System event logs contain information related to operations, such as automatic FortiGuard updates and GUI logins. User logs contain log-on and log-off events for firewall policies with user authentication. Router, VPN, WAD, and wireless subtypes include logs for those features. For example, VPN contains IPsec and SSL VPN log entries. Finally, security logs record security events such as virus attacks and intrusion attempts. They contain log entries based on the security profile type. Log type equals UTM, including application control, antivirus, DLP, anti-spam, email filter, web filter, intrusion protection, anomaly, DOS policy, and WAF. Security logs and subtypes are only visible in the GUI if logs are created within it. If no security log exists, the menu item does not appear. Each log entry includes a log level or priority level that ranges in order of importance from emergency to information. There is also a debug level. It puts diagnostic information into the event log. The debug level is rarely used, unless you are actively investigating an issue with Fortinet support. Generally, the lowest level you want to use is information, but even this level generates many logs and can cause premature hard disk failure. Depending on the type of log and the needs of your organization, you may want to log only notification levels or higher. You and your organization's policies dictate what must be logged. Every log message has a standard layout comprising two sections, a header and a body. The header contains fields that are common to all log types, such as originating date and time, log identifier, log category, severity level, and virtual domain, VDOM. The value of each field, however, is specific to the log message. In the raw log entry example shown on this slide, the log type is UTM, the subtype is web filter, and the level is warning. The type and subtype of logs determine what fields appear in the log body. The body, therefore, describes the reason why the log was created and actions taken by FortiGate. These fields vary by log type. In the above example, the policy ID field indicates which firewall rule matched the traffic. The SRCIP field indicates the source IP address. The DSTIP field indicates the destination IP address. The hostname field indicates the URL or IP of the host. The action field indicates what FortiGate did when it found a policy that matched the traffic. The MSG field indicates the reason for the action taken. In this example, the action is blocked, which means that FortiGate prevented this IP packet from passing, and the reason is because it belonged to a denied category in the firewall policy. If you log to a third-party device, such as a syslog server, knowing the log structure is crucial to integration. For information on log structures and associated meanings, visit http://docs.fortinet.com. Collecting logs from the devices in your security fabric is important. This is why 2 or more FortiGate devices and a FortiAnalyzer, a remote logging device, are requisite products at the core of the security fabric solution. With FortiGate, you can enable different security features like antivirus, AV, web filtering, intrusion prevention, IPS, and application control in different firewalls in the fabric. For example, in the internal segmentation firewall, ISFW, you can enable only AV, while in the next generation firewall, NGFW, facing the internet, you can enable web filtering, IPS, and application control. This means you do not have to duplicate scans and logs of the same traffic flow when it passes through multiple firewalls. The security fabric can provide a network topology view, physical and logical, and FortiGate devices can share network-related information. For example, devices connected to downstream FortiGate devices will be visible on the upstream device as well. You must enable device detection on the Interfaces page of the FortiGate GUI. In short, administrators can view logs and devices connected to the network by logging on to the root FortiGate in the security fabric. This information is securely shared using the FortiTelemetry protocol. It is important to remember that the more logs that get generated, the heavier the toll on your CPU, memory, and disk resources. Storing logs for a period of time also requires disk space, as does accessing them. So before configuring logging, make sure it is worth the extra resources and that your system can handle the influx. Also, important to note is logging behavior with security profiles. Security profiles can, depending on the logging settings, create log events when traffic matching the profile is detected. Depending on the amount of traffic you have and logging settings that are enabled, your traffic logs can swell and ultimately impact the performance of your firewall. From the FortiGate CLI, you can enable performance statistic logging for remote logging devices such as FortiAnalyzer and Syslog to occur every 1 to 15 minutes. This is not available for local disk logging or FortiCloud. You should always have a log management plan that addresses the following topics. What FortiGate activities do you want and need logged? For example, security features. What logging device is best suited for your network structure? Do you want or require archiving of logs? What is your backup solution in the event a failure occurs? You should also implement a remote logging solution such as FortiAnalyzer and ensure you plan for future growth. Finally, ensure you revisit your plan and backup solution frequently and configure alert messages that will notify you of activities that are important. Good job! You now understand log basics. Now you will examine local logging. After completing this section, you should be able to identify local log storage options, enable local logging, understand disk allocation and reserved space, monitor disk usage, configure behavior when disk is full. By demonstrating competence in local logging, you will be able to successfully store logs to local disk and retain those logs based on your requirements. You can choose to store logs in a variety of places, both on and off the FortiGate device. Storing logs on FortiGate is known as local logging. Depending on your FortiGate device, you can store logs either to the device's flash memory or hard drive. Typically, mid to high-end FortiGates have a hard drive. Logging to a hard drive is known as disk logging. Depending on the model series, disk logging may be enabled by default. Low-end and older model FortiGates typically have only flash memory. For flash memory-based FortiGates, constant rewrites to flash drives can reduce the lifetime and efficiency of the memory. As such, logging to flash is not recommended, and logging is disabled by default. Logging to memory should only be enabled on limited traffic and only while you are actively troubleshooting an issue. It should be disabled after troubleshooting has been concluded. For flash memory-based FortiGates, logging to an external device is recommended. FortiGates can store all log types, including log archives and traffic logs locally. Traffic logs and log archives are larger files and need a lot of room when being logged by FortiGate. Under heavy log usage, any logging to FortiGate, disk or memory will result in a performance impact. If you are using the local hard disk on a device for WAN optimization, you cannot also log to disk unless your device has two separate disks. You can use one with WAN optimization and the other for logging. If you are using the local hard disk for WAN optimization, you can log to remote FortiAnalyzer devices or syslog servers. If you want to store logs locally on FortiGate, you must enable disk logging from the Log Settings page. Only certain FortiGate models support disk logging. If your FortiGate does not support disk logging, you can log to an external device instead. You will learn about remote logging later in this lesson. Disk logging must be enabled in order for information to appear on the FortiView dashboards. If disabled, logs display in real time only. You can also enable this setting by using the CLI config log disk setting command. By default, logs older than 7 days are deleted from disk. Log age is configurable. If you decide to log locally on FortiGate, be aware that the entire disk space is not available to store logs. The FortiGate system reserves approximately 25% of its disk space for system usage and unexpected quota overflow. To determine the amount of reserved space on your FortiGate, use the CLI command diagnose sys log disk usage. Subtract the total logging space from the total disk space to calculate the reserved space. The Log Settings page displays two charts to visualize disk space. Disk usage, which is a pie chart illustrating the free and used space on the internal hard drive, and historical disk usage, which displays the volume of disk logging activity over time. These charts may not be visible if disk logging is disabled. The diagnose sys log disk usage command allows you to view detailed information about how much space is currently being used for logs. FortiGate uses only 75% of the available disk capacity to avoid a high storage amount, so the percentage refers to the 75% that is available. By default, when your disk is full, the oldest logs are overwritten. However, you can change this behavior to stop logging when the disk is full using the config log disk setting command. Before your disk reaches a full state, FortiGate sends multiple warnings. By default, the first warning arrives when the disk usage reaches 75%, the second warning at 90%, and the final warning at 95%. These thresholds are configurable using the config log disk setting command. Good job! You now understand local logging. Now you will examine remote logging. After completing this section, you should be able to identify external log storage options, configure remote logging, understand how remote logging works with VDOMs, understand log transmission, enable reliable logging. By demonstrating competence in remote logging, you will be able to successfully store logs on a remote device and secure log communication. If storing logs locally does not fit your requirements, you can store logs externally. You can configure FortiGate to store logs on syslog servers, FortiCloud, FortiSIEM, FortiAnalyzer, or FortiManager. These logging devices can also be used as a backup solution. Syslog is a logging server that is used as a central repository for networked devices. FortiCloud is a Fortinet subscription-based hosted security management and log retention service that offers long-term storage of logs with reporting. If you have a smaller network, FortiCloud is usually more feasible than buying a dedicated logging device. Note that every FortiGate offers a free tier and will keep logs for 7 days. You must upgrade to the paid service to retain logs for 1 year. FortiSIEM provides unified event correlation and risk management that can collect, parse, normalize, index, and store security logs. FortiAnalyzer and FortiManager are external logging devices with which FortiGate can communicate. You can place FortiAnalyzer or FortiManager in the same network as FortiGate or outside of it. While FortiAnalyzer and FortiManager share a common hardware and software platform and can both take log entries, FortiAnalyzer and FortiManager actually have different capabilities that are worth noting. The primary purpose of FortiManager is to centrally manage multiple FortiGate devices. As such, log volumes are limited to a fixed amount per day, which are less than the equivalent size FortiAnalyzer. On the other hand, the primary purpose of FortiAnalyzer is to store and analyze logs, so the log limit is much higher, though the limit is model dependent. Note that local disk or memory logging is not required for you to configure logging to FortiAnalyzer or FortiManager. Configuring FortiGate to send logs to FortiAnalyzer or FortiManager is identical. In order for FortiGate to send logs to either device, you must register FortiGate with FortiAnalyzer or FortiManager. After it is registered, the FortiAnalyzer or FortiManager can begin to accept incoming logs from FortiGate. You can configure remote logging to FortiAnalyzer or FortiManager using both the GUI and the CLI. GUI. On the Log Settings page, enable logging to FortiAnalyzer FortiManager and enter the IP address of the remote logging device. CLI. For both FortiAnalyzer and FortiManager, use the config log FortiAnalyzer setting command. Even though FortiManager isn't explicitly mentioned in the command, it is used for FortiManager as well. Using the CLI, up to 3 separate devices can be added to increase redundancy for the protection of log data. The commands for the 3 devices are not cumulative. Generating logs uses system resources, so if FortiGate frequently creates and sends logs to multiple places, CPU and RAM usage increase. Note that the test connectivity function on the GUI will report as failing until FortiGate is registered on FortiAnalyzer or FortiManager, as it is not yet authorized to send logs. FortiGate allows near real-time uploading and consistent high-speed compression and analysis to FortiAnalyzer and FortiManager. On the GUI, upload options include real-time, every minute, and every 5 minutes, default. If your FortiGate model includes an internal hard drive, you also have the Store and Upload option. This allows you to store logs to disk and then upload to FortiAnalyzer or FortiManager at a scheduled time, usually a low bandwidth time. You can configure the Store and Upload option as well as a schedule on the CLI only. If FortiAnalyzer becomes unavailable to FortiGate for any reason, FortiGate uses its MIG-LOG-D process to cache the logs. There is a maximum value to the cache size, and the MIG-LOG-D process will begin dropping cached logs, oldest first, once this value is reached. When the connection between the two devices is restored, the MIG-LOG-D process begins to send the cached logs to FortiAnalyzer. Therefore, the FortiGate buffer keeps logs long enough to sustain a reboot of your FortiAnalyzer, if you are upgrading the firmware for example, but it is not intended for a lengthy FortiAnalyzer outage. On FortiGate, the CLI command diagnose test application MIG-LOG-D6 displays statistics for the MIG-LOG-D process, including the maximum cache size and current cache size. The CLI command diagnose log kernel stats will show an increase in failed log if the cache is full and needs to drop logs. Similar to FortiAnalyzer and FortiManager, you can configure remote logging to FortiCloud on the Log Settings page or the CLI. However, you must first activate your FortiCloud account so FortiGate can communicate with your FortiCloud account. Once complete, you can enable FortiCloud logging and set the upload option. If you want to store your logs to disk first and then upload to FortiCloud, you must specify a schedule. When disk usage is set to WAN optimization, WAN-opt, the store and upload option for logging to FortiCloud is removed. You can also configure remote logging to Syslog and FortiSIM on the Log Settings page or the CLI. You can configure FortiGate to send logs to up to 4 Syslog servers or FortiSIMs using the config log syslog-d CLI command. FortiGate supports sending logs to Syslog in CSV and CEF format, an open log management standard that provides interoperability of security-related information between different network devices and applications. CEF data can be collected and aggregated for analysis by enterprise management or security information and event management SIM systems such as FortiSIM. You can configure each Syslog server separately to send log messages in CEF or CSV format. You can configure an individual syslog to use CSV and CEF format using the CLI. An example shown on this slide is for Syslog D3. All other syslog settings can be configured as required independently of the log message format, including the server address and transport, UDP or TCP protocol. If you have a FortiGate with virtual domains, VDOMs configured, you can globally add multiple FortiAnalyzers and syslog servers. On each VDOM, you can override these global settings, which allows you to configure only one FortiAnalyzer and/or one syslog server for that VDOM. The management VDOM is responsible for sending logs to FortiAnalyzers and syslog servers, so if a VDOM uses the override setting, then that VDOM is responsible for sending the logs to the new FortiAnalyzer or syslog server. FortiGate uses UDP port 514 or TCP port 514 if reliable logging is enabled for log transmission. Log messages are stored on disk and transmitted to FortiAnalyzer as plain text in LZ4 compressed format. This reduces disk log size and reduces log transmission time and bandwidth usage. When you enable reliable logging, that is, encrypt log transmission on the GUI on FortiGate, the log transport delivery method changes from UDP, User Datagram Protocol, to TCP, Transmission Control Protocol. TCP provides reliable data transfer, guaranteeing the data transferred remains intact and arrives in the same order in which it was sent. If you enable logging to FortiAnalyzer or FortiManager using the GUI, Reliable logging is automatically enabled. If you enable logging using the CLI, you must enable reliable logging using the CLI command shown on the slide. Logging to FortiCloud uses TCP, and you can set the encryption algorithm using the CLI. The default setting is high. Optionally, if using reliable logging, you can encrypt communications using SSL-encrypted OFTP traffic, so when a log message is generated, it is safely transmitted across an unsecure network. You can encrypt communications using SSL-secured OFTP by configuring the ENC algorithm setting on the CLI. Good job! You now understand remote logging. Now you will examine log settings. After completing this section, you should be able to configure log settings, enable logging on firewall policies, hide usernames in logs. By demonstrating competence in log settings, you will be able to successfully enable logging on your FortiGate and ensure logs are generated on traffic caused by traffic passing through your firewall policies. There are 2 steps involved in configuring logging. You must first configure the logging settings to determine if, where, and how a log is stored. You can configure these settings primarily on the GUI on the Log Settings page. You must then configure logging on your firewall policies to determine whether logs are generated. You can configure these settings on the GUI on the IPv4 policy or IPv6 page. The Logging Preparedness Checklist shown on this slide identifies what you need to configure for logging based on your requirements. The Log Settings page allows you to decide if, where, and how a log is stored. As previously discussed, you must configure whether to store logs locally on your FortiGate disk or remotely to an external device such as FortiAnalyzer. You must also configure what event logs and local traffic logs to capture. Local traffic logs provide information about traffic directly to and from FortiGate. By default, this option is disabled because of the large number of logs they can generate. Event logs provide all of the system information generated by FortiGate, such as administrator logins, configuration changes made by administrators, user activity, and daily operations of the device. They are not directly caused by traffic passing through firewall policies. For example, IPsec VPNs going down or routing protocol activity are not caused by traffic passing through a firewall policy. One exception might be the user log, as it does record user log-on, log-off events on traffic that passes through policies. The event logs you choose to enable depend on what features you are implementing and what information you need to get out of the logs. Lastly, you must configure how you want logs to display in the GUI. For example, you can specify whether the GUI displays logs from memory, disk, or FortiAnalyzer, resolves IPs to host names. This requires FortiGate to perform reverse DNS lookup for all IPs. If your DNS server is not available or is slow to reply, it can impact your ability to look through the logs, as requests will time out. While the log settings on the GUI allow you to configure what event logs and local traffic logs to capture, you can also set more robust and granular options using the CLI. Previously, we mentioned that you can configure up to 4 logging services for syslog and FortiSIEM using the command config-log syslogd setting, and up to 3 FortiAnalyzer devices using the config-log FortiAnalyzer setting. You can control what logs are sent to each of these devices separately using the command config-log syslogd filter for remote syslog or FortiSIEM, and the command config-log FortiAnalyzer filter for FortiAnalyzer devices. In this way, you can set devices to different logging levels and/or send only certain types of logs to one device and other types or all logs to others. For example, you can send all logs at information level and above to Forta Analyzer, alert level and above to Forta Analyzer 2, and only traffic logs to Forta Analyzer 3. After all your logging settings are configured, you can enable logging on your firewall policies. Only when enabled on a firewall policy can a log message, caused by traffic passing through that firewall policy, generate. Generally, if you configure your FortiGate to inspect traffic, you should also enable logging for that security feature to help you track and debug your traffic flow. Except for violations that you consider to be low in severity, you'll want to know if your FortiGate is blocking attacks. Most attacks don't succeed in a security breach on the first try. A proactive approach, when you notice a persistent attacker whose methods seem to be evolving, can avoid a security breach. To get early warnings like this, enable logging for your security profiles. To enable logging on traffic passing through a firewall policy, you must do the following. 1. Enable the desired security profile or profiles on your firewall policy. 2. Enable log allowed traffic on that firewall policy. This setting is vital. If disabled, you will not receive logs of any kind, even if you have enabled a security profile on your firewall policy. You can choose to log only security events or log all sessions. Security events. If enabled, along with one or more security profiles, security log events appear in the forward traffic log and security log. A forward traffic log generates for packets causing a security event. All sessions. If enabled, a forward traffic log generates for every single session. If one or more security profiles is also enabled, security log events appear in the forward traffic log and security log. After configuring logging, you can test that the modified settings are working properly. This test is done on the CLI using the diagnose log test command. On the FortiGate GUI, view the logs to see some of the recently generated test log messages. You can distinguish the test log messages from real log messages because they do not have real information. For example, the test log messages for the vulnerability scan contain the destination IP address of 1.1.1.1 or 2.2.2.2. On FortiGate, you can hide usernames in traffic logs and UTM logs so that the username appears as anonymous. This is useful as some countries do not permit non-anonymized logging. To anonymize usernames, use the Set User Anonymize Enable CLI command. It is assumed that logging is enabled in firewall policies and security profiles, and that identity-based policies are configured on FortiGate. Good job! You now understand log settings. Now you will examine how to view, search, and monitor logs. After completing this section, you should be able to view and search for log messages on the GUI, view and search for log messages on the CLI, view logs through FortiView, configure alert email, configure threat weight. By demonstrating competence in viewing, searching, and monitoring logs, you will be able to efficiently locate logs to help support your investigation into any network security issues. You can view your logs on the GUI under the Log and Report menu. The options that appear in this menu depend on your configuration. Security logs appear only if security events exist. Select the type of log you want to view, such as forward traffic. Logs on the GUI appear in a formatted table view. Formatted view is a more human-readable format than raw view, and you can easily filter information when viewing log messages this way. To view the log details, select the log from the table. The log details then appear in the Log Details pane to the right. If archiving is enabled on security profiles that support it, such as DLP, archived information appears within the Log Details pane under the Archive Data section. Archived logs are also recorded when using FortiAnalyzer or FortiCloud. If you configure FortiGate to log to multiple locations and want to view logs from those locations, you must specify the location on the Log Settings page. In this screenshot, it indicates the log location is set to disk, as that is the configured setting on the Log Settings page. If logging to a syslog, you must view logs on that device instead. Depending on your configuration, your FortiGate might record a high volume of logs. This can make it more difficult to locate a specific log, especially during an investigation. To navigate the logs more efficiently, you can set up log filters. The more information you specify in the filter, the easier it is to find the precise log entry. Filters are configurable for each column of log data on the display. Click Add Filter to select the filter from the drop-down list that appears. If you see data that you want to filter on in a log in the table already, you can right-click that data to select the Quick Filter option. For example, if you see an antivirus log in the table with a specific botnet name, right-click the botnet name in the table and a Quick Filter option appears that lets you filter on all logs with that botnet name. By default, the most common columns are shown and less common columns are hidden. Accordingly, if filtering data based on a column that is hidden, be sure to add the column as a selected column. To add columns, right-click any column field and in the pop-up menu that appears, select the column in the Available Columns section. If your search filters don't return any results when the log data does exist, the filter may be poorly formed. FortiGate looks for an exact match in the log, so you must form the search string correctly. You can also access log messages generated by individual policies. Right-click the policy for which you want to view all associated logs, and in the pop-up menu, select Show Matching Logs. FortiGate takes you to the Forward Traffic page, where a filter is automatically set based on the policy UUID. You are not restricted from viewing log messages on the GUI. You can also view log messages on the CLI using the Execute Log Display command. This command allows you to see specific log messages that you already configured within the Execute Log Filter command. The Execute Log Filter command configures what log messages you will see, how many log messages you can view at one time, a maximum of 1,000 lines of log messages, and the type of log messages you can view. Logs appear in the raw format view. The raw format displays logs as they appear within the log file. Similar to the GUI, if you have configured either a syslog or SIM server, you will not be able to view log messages on the CLI. FortiView is another way to view log data. FortiView integrates real-time and historical data into single summary views. It can log and monitor threats to networks, filter data on multiple levels, keep track of administrative activity, and more. On the various pages under the FortiView menu, you can investigate traffic activity and employ multiple filters to narrow your view over a specific time frame. Local storage is required to view logs 24 hours in the past. Note that some FortiGate models support a 7-day time display. This can only be enabled from the CLI using the Config Log Setting command. You can also save a FortiView view as a widget on your dashboard. Since you can't always be physically watching the logs on the device, you can monitor events by setting up Alert Email. Alert emails provide an efficient and direct method of notifying an administrator of events. Before you configure Alert Email, you should configure your own SMTP server on your FortiGate first. The FortiGate has an SMTP server pre-configured, but it is recommended that you use your internal email server if you have one. You can configure alert emails on the Email Alert Settings page. You can trigger alert emails based on event, such as anytime an intrusion is detected or the web filter blocked traffic, or on minimum log severity level, such as all logs at the alert level or above. You can configure up to 3 recipients. In order to prioritize solving the most relevant issues easily, you can configure severity levels for IPS signatures, web categories, and applications that are associated with a threat weight or score. On the threat weight page, you can apply a risk value of either low, medium, high, or critical to each category-based item. Each of these levels includes a threat weight. By default, low equals 5, medium equals 10, high equals 30, and critical equals 50. You can adjust these threat weights based on your organizational requirements. After threat weight is configured, you can view all detected threats on the Threats page. You can also search for logs by filtering on threat score. Note that threat weight is for informational purposes only. FortiGate will not take any action based on threat weight. Good job! You now understand how to troubleshoot communication issues. Now you will examine how you can protect your log data. After completing this section, you should be able to perform log backups, configure log rolling and uploading, perform log downloads. By demonstrating competence in the different ways you can protect your logs, you will be able to meet organizational or legal requirements for logs. You can also protect your log data by performing log backups, which is to say, copying log files from the database to a specified location. The execute backup disk all logs command backs up all logs to FTP, TFTP, or USB, while execute backup disk log type backs up specific log types, such as web filter or IPS, to FTP, TFTP, or USB. These logs are stored in LZ4 format and cannot be restored to another FortiGate. You can also back up logs to USB using the GUI. The GUI menu item appears when you insert a USB drive into FortiGate's USB port. Using the config log disk setting command, you can configure logs to roll, which is similar to zipping a file, to lower the space requirements needed to contain them so they don't get overwritten. By default, logs roll when they reach 20 megabytes in size. You can also configure a roll schedule and time. Using the same CLI command, you can also configure rolled logs to upload to an FTP server to save disk space. You can configure which types of log files to upload, when, and whether to delete files after uploading. You can also configure encrypted FTPS communication. You can also download a copy of the logs from FortiGate and save them on a server or on a computer to view and access later. This ensures that you still have a copy when the originals are eventually overwritten on FortiGate. You can download logs by clicking the download icon on the associated log type page, for example, forward traffic or web filter. This only downloads the logs in the results table, not all logs on disk. As such, you can add log filters if you only want to download a subset of logs. When you download the log messages on the GUI, you are downloading log messages in the raw format. Congratulations, you have completed this lesson. This lesson covered the following objectives: understand log basics, log workflow, log types and subtypes, log severity levels, and log message layout. Describe the effect of logging on performance. Identify local log storage options. Configure local logging. Understand disk allocation and reserved space, monitor disk usage, and configure behavior when disk is full. Identify external log storage options. Configure remote logging. Understand log transmission and how to enable reliable logging and OFTPS. Configure logging settings. Understand MIG-LOG-D. View and search for log messages on the GUI and CLI. View logs on FortiView. Configure alert email and threat weight. Configure log backups, rolling, uploading, and downloading.